you can hear from 120 decibel to 50 decibel, for example. But you can see the frequency content of sound was changing. In the beginning, you have right? Right? Why? Why? Because this is nonlinear system. In the beginning, amplitude is large. The stiffness of this membrane in the beginning is different with the stiffness afterward. So in the beginning, the vibration of this plate involves many different frequencies that can be involved in the later. Very interesting musical instrument. You might have a similar musical instrument in Indonesia, but different size. But different sound. Different sound, right? Yeah? Different sound. This is generate very smooth sound. Reason is, over here you will see this part is hammered. Okay. When you solve plate with a circular boundary, then sorry about saying the eigenfunction, eigensolution related with this fantastic musical instrument, but it's interesting. The eigenfunction or eigensolution that satisfy the plate vibration, okay, with a circular shape, will be the solution of eigenfunction would look like a Bessel function. Bessel's first and second type. Okay, the eigenfrequency of that corresponding Bessel function is not equally spaced. In other words, it's not harmonic. It's not harmonic. Therefore, this one generates. This is not harmonic. That's why we hear gang, gang, gang. This is not harmonic. Okay. This is a harmonic, right? That means the frequency distribution is like when I have 200, so 400, 600, that is harmonic. That we hear very smooth sound. But if it's not harmonic, so Gangari, the thickness of Gangari is uniform. But thickness of this Jing is not uniform. It's thin and then gradually thicker. So the solution, eigenfrequency of this plate is more harmonically spaced. They didn't make this by solving eigenvalue problem. What they do is they just hammer this and they hear the sound. So in Korean we call this 방자 jing. 방자 means we hammered. Okay, this jing is very unique. You cannot find this kind of jing, musical instrument in China or Indonesia or in Japan or elsewhere. This is very harmonic, generate very harmonic sound. And this one, it's not harmonic, but transmit the signal to the audience, which we call the main signal or melody signal to the audience very well. Then you hear somebody just right? So that demonstrate the directivity of trembling sphere. Okay? So this concludes the lecture, and on coming Thursday we will talk about sound radiation from baffled piston, and then you will see that directivity does depend on frequency. Okay? Okay, see you guys the next Thursday. And I will give you homework on Thursday because there was no homework on the last week. I didn't give you homework, right? And nobody sent me an acknowledgement email. I was really disappointed.